Why is bioremediation important? My mother is from Haiti of the Caribbean islands, and my father is from a small country called Togo, which is just on the coast of West Africa between Ghana and Benin. I've been to Haiti multiple times, but I only got the opportunity to go to Togo once, and when I went, I absolutely loved it. I stayed half of the time in Lomé, the capital city, and the other half in a small community called Pele Chico, but sometimes we just call it Pele. There are a plethora of things that you can do when you're in Pele. You can hike through the mountains, swim through the waterfalls, buy waist beads at the street markets, or, my personal favorite, enjoy a freshly ripened orange down at the fields. Now, as fun and exciting as my time was in Togo, it was also very eye-opening. Eye-opening in a wearying sense. The lives of the people there are very different from how ours are here. It's appalling how I was able to take multiple sips of water throughout the introduction of my speech, and none of you, including myself, even batted an eye at it. Everywhere we go in the United States, public fountains, bottles, gallons of water sold to us daily. When you sit down at your favorite dining establishment, you are immediately presented with an ice-cold glass of water. None of us take a second to think, is this water okay to drink? We just assume that it is, because we know that it is. Swig, swig, our needs are constantly met. But it's not like that over there. During my time in Togo, we visited the oldest city in the country called Togoville. It's about 20 miles wide, and it houses around 20,000 people. When we were there, we visited a lot of the historical attractions in the area. And one of the attractions in particular was this dug well. It had the numbers 1910 engraved on it, and it was right in the city, in the center of a small community of homes. And as we were looking at this well, I thought to myself, wow, it must be so amazing that the people here are living so close to such an important historical artifact. They must feel so connected to their heritage and their culture of the country. As I thought this, a lady walked by me with a bucket and a rope. She proceeded to drop that bucket deep into the well and pull out some water. I will never forget the look of the water that she pulled out of this well, looking murky, tinted, populated. She took this bucket, went back to her house, distributed some of it into her clothes washing bowl outside, and brought the rest of it inside, probably to drink, cook, clean, or what have she. Me, I was puzzled and distraught. How fortunate am I to go back to the United States and have the cleanest water that I've seen since I left the Togolese countryside? It just wasn't right. So this here is a picture that I took of the well in my trip of July 2021. And this is a picture of that same well during my sister's trip in October of 2024. 3 years later, there's no difference. They're still using it. So that's the well, but what is the issue with this well? This well is a concrete dug well. Dug wells only go down about 10 to 30 feet into the ground to a water source called shallow groundwater. Now, this well doesn't have a covering on it, so it collects rainwater and the groundwater, which is runoff from the Lake Togo, which is right nearby. Now, keep in mind, 10 to 30 feet underground is not very far from where the Togolese people would bury a human life. Would you drink that water? I sure wouldn't. So I took this information with me to my freshman year pre-honors biology class, taught by the amazing Mrs. Diane Enton. During our What We Did This Summer spiel that I shared with the class for a little icebreaker, I mentioned my trip to Togo. And I also talked about the well. In one of our biology labs a few weeks later, Mrs. Enton invited me to join her after-school independent research honors class. I agreed, and I went back the following Wednesday, the next week. Sitting in the back of the biology room that I knew so well, I felt like a complete stranger. Not only was I one of few freshmen that's in a class that's normally introduced to exemplary sophomores, I also didn't think that my project ideas didn't live up to those of the amazing competitors that came before me. Mrs. Enton noticed my fear and my frustration, so she invited me to come after school the next day for a one-on-one with her. During our one-on-ones, we were supposed to fill out an idea sheet of 3 ideas that we wanted to do for our project potentially during the year. I remember all of my ideas on that idea sheet involved a key characteristic that I carried with me throughout my entire high school research initiative, a natural remedy. Natural remediation has been in my family for ages, not just the Aluka hood, as my family calls it, but also my Togolese and Haitian culture. I remember being really young and fearing to tell my dad that I was sick because he would always have some warm yet bitter tea to give me or some stinging droplets to put down my nose. As uninterested as I presented myself to be towards his natural remedies, I secretly marveled at his knowledge of alternative medicine. How embarrassing, but it's true. So Mrs. Enton connected me with another student who also wanted to study remediation, and he and I decided to compare natural and industrial methods of water filtration. The first step was to pick out the way we were going to simulate real-life contaminants of water. First, we picked lead nitrate, which comes from North American pipe erosion, and is also the primary contaminant in the Flint, Michigan lead water crisis that's currently ongoing. Second, chlorine bleach, which is used in large-scale filtration and is very dangerous for at-home recommended use. Third, a bacteria called Serratia marcescens, which can be found in places like the dug well in Togo, and also places like tiles, kitchen sinks, things of that nature. Finally, Escherichia coli, commonly known as E. coli. It's a coliform bacteria that can be found in human bowel systems and also animal excrement. So the easy part was done, finding our 4 contaminants. But how are we going to remove these contaminants out of water naturally? I was assigned to pick out our natural filtration methods, and I remember a plant that my dad used consistently in a lot of his remedies. Moringa oleifera. The seeds, the flowers, the leaves, and the roots of the moringa plant can be used for a wide variety of all different types of medicines and facilities. So I did some research, and I came across a method created by Bob Tilton and Todd Presbysian, the moringa seed and sand filter. The effectiveness of this filter comes from the MOCP protein found in the moringa seed. The MOCP acts as a molecular knife and cuts through the cell membranes of the bacteria contaminating the water. Tilton and Presbysian found that after 24 hours, the bacteria regrew in the water because of organic material left over there. So they added something called F-sand. F-sand was able to catch the remains of the bacteria and allow for 100% of the contaminants to be removed. Okay, great. We've got our first filtration method. Sounds perfect to study. Let's get to work. No. Freshman year me wanted to do another one. So I did some more digging, and I came across a method created by Dr. Ramakrishna Malampati called the Malampati method. The Malampati method features dried apple and tomato peels. He used this method to filter harmful anion chemicals out of water. Through a reaction called adsorption, the negative chemicals are attracted to the zirconium element in the peels. So once they are attached to the peel, it is then taken out of the water and the contaminants come with it. So we had our 2 filtration methods. We compared them to 3 industrial methods: the Brita filter, the boiling water method, and an activated charcoal filter. And thus we had our project title, The Economic Bioremediation of Eutrophication. 2 long school years and 120-something data samples later, it's finally time to analyze our data. I remember staying up late one night, sophomore year, and compiling our data into this graph, and I cried a few tears of joy. Let's focus in on our 2 natural filtrations. It was appalling that the moringa seed and sand method and Malampati method were able to result in the highest amount of percentage contaminant removed across 5 different filtration methods and for 4 different contaminants. In addition, the boiling water method was also our 3rd highest performing filtration device, and it's one that I actively use at home. So I cried a few tears of joy, but at the same time, I cried a couple tears of sadness too. This graph is a representation of how simple it is to create change for people like those in Togoville. Aside from Togo, according to worldvision.org, there are 54% of people in Niger, 54% in Chad, 50% in Ethiopia, and 48% of people in Eritrea are living without clean water today. Now that's just a small amount. Imagine the billions of people across the world that are living without clean water that we get like this. To think that plants regarded as underutilized as the moringa plant, or peels like tomato and apple peels that we throw away daily that are regarded as waste, can be used to create something amazing, can be used to save a life. It just isn't fair. So, even though our project focused on natural filtration methods and they were extremely effective in a lab scale, on a larger scale, it'll take many, many years to develop a good enough method to use on a widespread area like in Togo. So the MOCP and zirconium atom were very effective, but we need to go back to what works: technology. Waiting around to create a natural method will take years, but water is inaccessible today. So let me introduce to you my project, Togo Together. Working alongside an organization based in Togo, JVE, or Youth Volunteers for the Environment, I connected with a sociologist, Ms. Elodie Wilhelmina, to conduct a survey in Togoville to the residents to see what exactly they needed from us. I compiled the results into 3 main points. First, water is inaccessible. The people of Togoville rely on the Lake Togo at the edge of the city and the 2 dug wells that I talked about in the center of the city. So this city is about 20 miles wide, so they're probably walking about over 5 miles to the well or over 20 miles to the edge towards the lake. Now, this really is not healthy for people to do on a daily basis. Secondly, water illnesses are going untreated and undetected. The residents that responded to the survey all indicated that Togoville does not have a hospital, and the people there are extremely ill, and they don't really know why. I believe that the root of this cause could be their water sources. They also indicated that they only use cloths to filter their water, which is not very reliable at all. Finally, water is scarce. The dug wells in the center of the village only produce 5 gallons of water a day. Compared to what we see at the grocery store, that's not a lot. So, with Togo Together, I am raising funds to build a drilled well in Togoville. A drilled well, opposed to a dug well, goes down over 1,000 feet into the ground, and it collects water from the purest water source they have, the aquifer. Not only is it covered to protect from rainwater and other outside contaminants, it also can eventually create distribution pumps that go across the city to allow people to walk much less to get their water every day. So, even though Nicholas and I only won 3rd place in the science fair, we were still able to turn our project into something tangible, something amazing, something that helps people and saves lives. It is time that we started remediating the things that we obtained so easily so that other people have the privilege of doing this safely. Thank you.